Okay, so in this video, we're covering pandas. And this is such an important Python library for data science. It's built on top of NumPy, and it's the go-to and standard way to deal with tabular data or stacked tabular data. So for example, a Microsoft Excel sheet or a CSV file. This is where Pandas comes into play. And it's also just great for manipulating this type of data. There's just so many different uses for it, and you'll understand why as the semester goes on. And we will import this library with the alias PD. That's the standard way of doing it. And in this notebook, I'm going to work with a CSV file that I have saved on disk. So currently, if I look at where I am in Documents Test, RICE 22, Data Science Machine Learning, Lecture 2. So this is where I'm at, okay? And I understand exactly where I'm at on disk, like where my path is, I mean. And inside of this folder that I'm in, Lecture 2, I have a datasets folder. And inside of this datasets folder, I have an iris_dataset.csv file. This is what it looks like, comma separated and delimited file. There's a description in the notebook about what CSV files are, but this is data. It's a way of storing data. You can have this as an Excel sheet as well, but CSV files are common, and that's what we'll work with today. So in order to read this data in using Pandas, I need to know exactly where it's at. Okay, this is because when you use the Pandas read CSV function, or if you're reading in an Excel file, you need to know the path, the location of where the data is. So I know exactly where my data is. I know that I'm currently here, and if I look at data sets and then go inside of data sets, Iris data is inside of there. So on Mac OS, the location would be datasets/iris_dataset.csv. That's the exact location of where the Iris dataset is in relation to the notebook that I'm currently in. If I was in Windows, it would look like this, \. Okay, so you have to be aware of that. There is a way to work with it, but I don't want to talk about that right now. The easiest way to deal with this, if you don't want to have to deal with the paths, is to say, put your Iris dataset in your current working directory, and then just read in the name of it inside of strings. Okay. So if you have it in your current working directory, you can just give the name. But mine is in a datasets folder, so I have to access that folder and then go inside of it. So your code will probably look different, especially if you clone this or you got this from my GitHub account. Or if you did get it from my GitHub account, it will look similar. But if you got the notebooks and the data from Canvas, be sure to put the Iris dataset in your current working directory and just read it in as a string iris_dataset.csv. Or if you made a datasets folder, make sure that you give it the correct path, depending on the operating system that you're in. All right, so we're getting so close to diving in to the actual core content of the course now, because I'm doing this. Pretty much every Jupyter notebook that we work through from here on out, you will import these three things every single time. Okay. So up next, after I import these modules, I set a variable called iris equal to the pandas.read method, and it's reading in this location. So on my computer, it's inside this folder, and this is its name. And then after I read that in, I'm going to print out the type of this variable. This is a data frame type. Data frames are the main object that you will work with when dealing with data and using pandas. They're also used in R, so some of you might be familiar with them. They're a tabular format for the data that's stored as a CSV file or an Excel file that you can work with in Python. To view it, there's two different ways. Okay, you can print the data frame. So this is just printing it out. Or in Jupyter Notebooks, you can just put it at the bottom of your cell and run. They will look different, but they're the same thing. So if you print the data frame, it will look like this. If you just run it, it will look like this. Okay. So this is the tabular format for the CSV file that we read in. And we see up top, we have columns, right? And we have row numbers, and we'll get to that in a bit. Sometimes though, when we're dealing with large data frames, we only want to look at the beginning or the end of the data frame in question. We can do that or achieve this by calling the method head for the first 10 rows in this case, or the method tail for the last 3 rows. These are the last 3 rows down here, and then these are the first 10 rows. And you can also leave off, you don't have to put in a number, you can just call it like this, and it will default to 5. But you can specify how many rows you want to look at. Okay. So what are we dealing with here? Like, in fact, let me just make a new cell here and then just call iris. Why is this useful for us as data scientists? So first off, this is real world data. This data set we're dealing with is often referred to as the hello world of machine learning data sets. It's the data set where you start off building your first machine learning algorithms from. Okay, it's a really famous data set. It consists of 4 different measurements of 3 different species of flowers. So we have 4 different numerical measurements, and then we have a categorical measurement, i.e. the label, and those consist of 3 different species: Setosa, versicolor, and virginica flowers. And you can see that they kind of look alike, right? So if we go back to our data now, these data frames are storing this information in a way that we can work with, okay? So each column is a single measurement over many different instances of species in this case. Each row is a collection of measurements over a single instance. So if we're looking at flower 0, it has sepal length 5.1, sepal width 3.5, petal length 1.4, petal width 0.2, and then its label is Setosa. Okay, so this row is for that given instance of that flower, and then this column is every instance of flower, that measurement. Okay. So we can access the columns in the rows by calling these 2 attributes: the columns attribute and the index attribute. And we don't have to talk about it yet, but we will talk about how the rows in a data frame are represented in a later lecture. For now, just know that each row is labeled between 0 and 150 with step size of 1. And if we look at our data frame, we'll see that in bold: 0 to 150 non-inclusive with step size of 1. And if we look at the columns, we get a list of strings that are these bold column names here. Okay. Now, it's often the case that we'd like to access a single column from the data frame. And there are 2 different ways to do this. There is using the dot notation. So you access your data frame dot the name of the column exactly as it appears. Now, sometimes when you read in data frames, there will be spaces in the names of the columns. For example, it might be sepal length space length. In that case, you'd have to change the names of those columns. And we'll talk about that in the next lecture, actually. The next way, and I think is the preferred way when being as clear as possible and like being as cautious as possible, is to pass into brackets the name as a string of the column in question. So let's just look at this sepal length column and verify that this works. Okay, so maybe I'll put in a little new line character there to separate them a little bit. So iris.sepal length gave me this, iris brackets string sepal length close brackets gave me the same exact thing. Now notice that this returns a type series. So this is not a pandas data frame. This is a pandas series type. Pandas series are essentially one column data frames, but they have different, the methods are different and the attributes are different. They don't share everything, but you can for now think about them as single column data frames. For example, if you would like to convert, like you might sometimes want to convert a series to a data frame. Well, if you wanted to do that here, I could say pd.data frame to convert this series back to a pandas data frame. Oh, missing a parenthesis. So now you see that they appear different. I more often than not will convert a series back to a data frame immediately when I'm working with the data. Okay. So next up, if we want to access multiple columns, we pass into the brackets of the data frame a list with the names in string form of the columns we want. So for example, if we wanted to access the sepal length and sepal width columns, we'd pass in a list with those names. And notice now that this is definitely a data frame. If it appears like this, it is a data frame. And we could check the type even if we wanted to. So if we access more than one column, it turns it into a data frame. If it's a single column, it's a series. Okay. Now, the rows of the data frame can be accessed in two different ways. With this current data that we have, there's only really one way to do this, and we will experience other ways. But for now, to access the rows, we're going to use the iloc method. I think of it, this might actually be the name, the integer index location method. So iloc, you pass it in an integer value, and it specifies in this square information or this rectangular information, it accesses that row, right? If you think of it like a matrix. So this should be the 0 row. And then you can also slice iris.iloc 0:50. This should slice the data frame and look at only the first 50 rows. So if I copy that and run it, you see that the 0th row is this list of information here, list of data, just on that row. But then if we look at every row between 0 and 50, it's all of this chunk. Okay. So for now, use iloc, but there will be a time when we have to use loc, which could be a string location on the row axis. For example, date is often another way of indexing on the rows. Next up, and a common task that we will encounter, is accessing data subject to some Boolean condition. So suppose this data was messy and it wasn't ordered the way it is, because if I look at it, I see that there's nothing but setosas in the first 50 rows. The next 50 rows would be a different species. It's all collected in a very organized way. But suppose that wasn't the case, and I wanted to only access the rows where the species column entry equaled setosa. Well, if I look at the iris.species, if I look at this column, recall that this is the column, the species column, double equals, where does that equal setosa? That's what this is doing. This will return a, well, let's just run it actually before I start talking. It returns a pandas series. And notice it has the same, like there's 0 through 149. Those are the index values for our data frame. And it's true at the first 50 and false everywhere else. But this is sometimes useful, but really what we want is the data, like the actual numerical values where the iris species is setosa. So the way that we do this is by looking at our data frame and then passing into square brackets that given series that we just looked at. So if we pass this series into our data frame inside of the square brackets, it will return to us the entries in our data frame where that's true. So we go from a Boolean series to actual data by passing it in to those square brackets. Okay. So that's really useful to do. Next up, we would like to make a new column. Okay. So notice that the labels or the species for, I'm kind of jumping ahead by saying labels, but essentially we have 4 different measurements, and for each of those numerical measurements, we have a label for what it is, right? And a common task in supervised machine learning is to predict the label, right? And currently the labels are strings, right? The name of the species. To implement our algorithms, we would like to have numerical labels. So we need to possibly add another column of data that says that Setosa is, for example, labeled 0. So all Setosa flowers are labeled 0. All versicolor flowers are labeled 1, and Virginica are labeled 2, or something like that. So we want to add a new column of data. So I make a quick function here, and I say that, so make target, so this is a function. It takes in a variable called species. If species is equal to Setosa, I return 0. If it's versicolor, I return 1. Otherwise, I return 2. So then I say iris brackets target. So this is not currently a column name. So what this is doing is making a new column is going to be equal to this business here. Now, you have not seen this before. I'm calling list. So list function is converting whatever is inside of here to a list. So at least you might know that. But inside of that function, I have another one called map. So the map function takes this function that we just made called make target and applies it to each of the entries in this array, or in this case, this pandas series. Okay. So this is making a list of values equal to 0, 1, or 2. And that's going to be the assignment of this column. So if I copy that and run it, I see that now I have a new column called target, and 0, 1s, and then 2s. Okay, so that's how you make a new column. Now, as I mentioned at the beginning of this recording, Pandas is built on top of NumPy, right? So a lot of the same attributes and that you have on NumPy arrays will apply to, or some of them will apply to Pandas series in Pandas data frames. So for example, if I want to know the shape, which gives me the dimensions, if you recall, of the data frame, I just called the shape attribute. We can also convert the series to a NumPy array with the toNumPy method. So this is iris.sepalength is a Pandas series, and then .toNumPy converts that to a NumPy array. And this is just printing it out, what it is. And then we can also do the same thing with multiple columns. So for example, I'm converting the sepal length and sepal width ilog. So the first 25 rows of sepal length and sepal width data, I'm then converting it to a NumPy array. So let's run this and just verify that it works. There we go. So this is the sepal length column converted to a NumPy array. This is the sepal length, sepal width columns, rows 0 through 25 as a NumPy array. Okay. All right. So next up.
Sorry, quick question.
Yes.
So when we are performing these operations, they're not returning to any value, right? They're just displaying it. Right.
If you would like to use it, you would set it to a variable. This is not mutating the data frame. It's returning it. It's returning a new one. And if you want to use what it returns, you should set that equal to a variable and then act on that variable or use that variable.
However, when you were adding a label, the target label, it changed.
That does mutate it. Yes,
okay.
that does add a new column.
Okay.
Okay, so next up we have visualizing the data. So this is the fun part. Now, in order to visualize this, I'm going to use a library just barely. This is the Seabourn library. This is a fancier and more statistical plotting library that's built on top of matplotlib. Okay, And we'll use this during the semester, but I won't go into the details of it. You'll just pick it up as we go. And for our purposes in this video, I'm just using it to set the theme because I wanted to change the background theme. I was tired of looking at white figures. I wanted a darker theme to my figures. So all I'm doing here is setting the theme to be Seabourn, which means it's going to have a gray background. And then you should recognize this. I am making a blank figure of this size, but now I'm also changing the DPI, which will make it a little bit clearer to look at. Next, I grab the species, and I've talked about this before. You have a big long list of possible species. I make a set out of it so it gets rid of duplicates, and then I convert it back to a list. All right, so it's just getting the species. Next, we're going to look at color and species in zip of these two lists. So zip is pairing the 0th entry in this list with the 0 entry in this list. So it looks like magenta will be the first color and the first species will be Setosa. So when we enter into this loop, we're looking at color equals magenta and species is Setosa. So we're inside the loop. Temp iris is going to be a new data frame that's equal to, as we were just talking about, a data frame that's generated by all the data where the species is equal to, in the first case, Setosa. So this is my temporary data frame. And then I'm going to scatter. I'm calling the plot scatter method. And then I'm scattering what? The sepal length is my X, the sepal width is my Y. And this is only for values in temp iris, which I know belong to whatever species I'm looking at. Then I set my color. So C is a keyword argument to be, at first it's going to be magenta. I set my size of the markers to be a multiple of the petal length of that data. So this is a way of visualizing three-dimensional data in 2 dimensions in the Euclidean plane by adjusting the size of the markers by a third measure. Alpha is the transparency of the dots, and the label will be the species. So the first species will be colored magenta, the next one will be colored sea green, and the final one will be blue. And then after I exit out of that for loop, I put my label as sepal length. It's in centimeters because I've dealt with this data set so many times. Y label, sepal width, title, iris data, X lim. I'm setting how wide I want my X axis to be. Set my legend, and I show. So let's go ahead and run this. And this is the image that we get. You can see that the size is relative to the sepal, the petal length, but on the X and Y axis, we have the sepal length and sepal width. The colors match up. We have blue Setosas, green Virginicas, magenta Versicolor. And it's a nice looking figure. I hope that you would agree. Okay. Now, there's one method from Seabourn that I think might be useful to look at. And that is the Seabourn pair plot method. There's some warnings here, it's fine. So this is the Seabourn pair plot. Now, if you look at this, like for example, I'm gonna look at sepal width. So this is this column here. Sepal width versus sepal length is this plot. Okay, and then we're looking at distributions of values along the diagonal. And then we could probably get rid of target. We should probably get rid of target before we've made this because target is just the 0s and 1s and 2s. Okay, but this is a nice way of visualizing the data, especially when you're testing to see which features you would like to use to maybe perform linear separation on, like you want to do classification between 2 different species. So for example, out of all of these plots, I see that maybe this one right here, this so petal length and petal width, this plot, there's a line that we could easily find to predict whether or not you're Setosa or Versicolor or Virginica. And this one too, right? Out of Versicolor and Virginica, which plot is the best? Like this is terrible. They're all over each other in that one. but maybe this one is okay to try to find a line to cut and predict whether or not you're orange or green or versi color virginica. Maybe this one, this is a way of visualizing it, and it's really useful to look at. Okay, so that will conclude our video running through the basics of using pandas. Okay.